or in forensic forensic exercises, when people have to use forensics to analyze crimes or explosions by military explosives. So it's important to know. There's RDX, which is usually called C4. This is a polymer that has a whole bunch of nitrates in it. So it doesn't really have much of a chemical formula, except there's a lot of carbons and nitrates all throughout the polymer. It's like a dough-like consistency, really easily molded with the hand. And of the military explosives, this is the most powerful one. They're the most popular ones of the powerful military explosives. It's very easy to set a charge using a C4. It really is rather stable until you use either an electrical charge. You can actually use a bullet to blow the whole thing up too. But anyway, it's popular and it's a military explosive. We also have trinitrotoluene, that's TNT. This is common. It's found in grenades in the military. Also satchel charges, where you basically fill a knapsack up with this stuff, and that blows up a lot. That's trinitrotoluene. If you know your organic chemistry, very easy to synthesize that, but I'm not telling you how. We also have PTN. This is usually used in rope-shaped explosives, mostly as a detonator, to detonate many charges at the same time. We have this rope lead to, let's say, 4 different satchel charges. So when we react the PTN, that rope leads to these 4 satchel charges. So detonating PTN will detonate all 4 satchel charges. It's a way of getting explosions in wherever you want the explosions to be. That's what PTN is. Now, you might think it's not relevant because in the United States, military explosives are not used. The military has a tight rein on them, so it's hard to get the hands on military explosives. Other countries, however, forensics do occur in other countries too. They don't have the same security as the United States military, so they can be bought or stolen by criminals and terrorists. So also, some other countries, they actually don't mind selling them to unscrupulous buyers because they want the money more than they want the explosives for whatever reason. So not only is the security not is lax, maybe they don't even have any security at all. There are also countries like Iran that they actually don't mind at all selling these military explosives to terrorists because they like what the terrorists do, like Hezbollah. Iran, they fund Hezbollah. They donate all these military explosives to Hezbollah. So this also happens. So these things can occur in crimes. They can occur in terrorist activities, and it's up to the forensics to understand more about them and to prove various aspects of the crimes that were done with them. They also need detonators. Now, we mentioned the primary explosives. These are high explosives that they need to make a small explosion, so that the main high explosive, whatever it might be, C4 or TATP, the tungsten triperoxide, so that will get going. But you need a small explosion to get that started. So these are the primers mentioned before as primary explosives. So these are generally unstable chemicals. We have the copper aluminum case. We need good cases because we don't want them to blow up. We only need a little of them, well encased and safe inside these cases until the time comes for them to detonate, when they will blow up a little bit because there's only a small amount of them, and they will ignite the larger, let's say, C4 explosive. So lead-acid, this is PBN3 taken twice. Lead-acid is unstable and it's often used as a primary explosive. PTN, it was a high explosive, but it can also be used as or even C4 can be used even as a primary explosive. These are they're more stable. They're more stable to start with, but nevertheless they're actually used as a primary explosive sometimes. These things, like the lead-acid, is detonated by an electrical charge. Sometimes even a fire can do it. For lead-acid, it's an impact can do that. But we have these primary explosives that get detonated by an electrical charge. And this will ignite the main explosion from the high explosive and which will cause the real blast and the real damage and the real explosion. So the key is to get these little things detonated, let's say from far away, because of course the criminal does not want to be there when it explodes. So the remote detonation comes from clocks. That when the hand reaches a certain place, which is attached to a battery, the hand reaches a certain place, it'll connect a circuit, and there goes, and your electrical charge will get into this primary explosive, setting off the main high explosive explosion. Also, they're attached to cell phones. Cell phones have a burst of electricity when you call them. So that's what's done. You attach a cell phone, and if you know your wiring, you attach that to the primary explosive, and you call the cell phone. It'll ignite, again, the primary explosive ignites, blasting off the secondary explosive. So that's also a way to remote detonate a remote way. Homemade time bombs. The tripping mechanism is done with a mercury switch. Mercury is a metal that's a liquid. So when you tip the mercury container, the liquid will, let's say, spill or be channeled into like a cup, which has electrodes on both sides. The mercury is a metal and therefore an electrical conductor. So when the mercury gets into that, let's say, cup or that channel or that space, the electrical circuit will be completed, sending off the electricity to the primary explosive, blasting that, and therefore the entire high explosive. So that's very common. It's apparently the most common one in homemade time bombs. There are car bombs also where they put the high explosive, but this starts with the ignition. The car's ignition makes an electrical spark. I mean, that's how cars work. You turn the key, the electric spark goes into the engine with all the gasoline, and the gasoline explodes. But this electric spark will also provide the electricity for the primary explosive, and therefore the secondary explosive to blow the entire car up. There are also booby traps that have the metal parts. That they have a battery, and there's the metal parts. When the metal parts are connected by a person stepping on, let's say, the top metal part, then the top metal part contacts the bottom metal part, and then now your circuit is complete. Electrical charge goes into the primary explosive, blowing everything up. This is often found in mines against vehicles and people. I mean, you put the mines in the road and blow up vehicles or people. If people step on it, it'll blow everything up there. So now the issue for the forensic people is to try to find out from what remains what happened, and try to get some evidence from there. Inevitably, someone will react to explosions, because remember, this is a blast. It can blow away some of the reactants of the explosive before they'll actually react, because again, it produces a very fast, high pressure wave. So some things will remain unreacted. Inevitably, there will be unreacted explosive. The question is finding it. So we usually find them near the source of the detonation, and the soft and porous materials, wood, cloth, if you can find it, they will pick up this unreacted explosive. Sometimes even non-porous materials can have the explosive material blasted onto them. A very important place to check are the cracks and threadings of the explosive device. Let's say of a pipe bomb. Look at the threading of the pipes. Look at the cracks inside the device used